In the last video, we looked at the try-catch clause with checked and unchecked exceptions. I also talked about using the finally clause as a way to close resources. Since JDK 7, there's a better alternative to this approach. To demonstrate this, I'm going to use the file exceptions project from the previous video. Here, I'm using files.readAllLines, which is one way to read data from a text file. An alternative is using a class called FileReader. Later in this section, I'll cover some of the numerous ways you have to open and communicate with files, but right now I still just want to focus on exceptions. I'll first comment out the readAllLines statement. Next, I'm going to declare and initialize a FileReader class, passing my filename string to the constructor. This class has methods on it to read data in from a character file, but for now I'll just instantiate it. Notice that IntelliJ is highlighting the FileReader type here. Let's see why. Hovering over it, I can see it says that FileReader is being used without a try with resources statement. Try with resources was introduced in JDK 7 as I mentioned. If you do use a traditional try-catch block with classes like FileReader that implicitly open a resource, it's very important to include closing the resource in the finally block. Let me show you what this would look like in my private method test file. First of all, I need to declare my FileReader variable outside of the try-catch block so that it will be in scope for the finally block where I need to close it. I'll copy the declaration part of the statement and paste that on the line above the try clause. I'll initialize that to null. Next, I'll remove FileReader as the type in the try block because otherwise it's a declaration of a new variable. I'll close the reader manually in my finally clause before that last println statement. I want to check and make sure the reader variable is not null. If it's not null, I'll call the close method. I get an error showing because the close method throws a checked exception. I have to choose to catch or specify. I'll use IntelliJ's help to enclose that statement in a try-catch block. Okay, so this code has gotten a bit ugly pretty quickly. Before JDK 7, this is how you would have closed a file resource. I'm going to leave this method as is, and now create a second one called testfile2 with the same signature as testfile except the name. I'm going to start like I did before with one statement that instantiates a FileReader instance using the file name argument. I'll also include that last print statement. Not surprisingly, we know this will give us a compile error because of the unchecked exception. I'll select more actions. And now what I want you to see are the options below the first two we looked at previously. Notice the very last one, surround with try with resources block. I'll select that one. IntelliJ has inserted some code surrounding our statement. This try block is different because now it's got a set of parentheses associated with it. In those parentheses, I have my FileReader instantiation statement minus the semicolon. These differences are a little easier to see if we look at them side by side on a slide. The try with resources takes a colon-delimited list of resource variables. The resources in this list must implement the auto-closable or the closable interface. The closable interface extends auto-closable as of JDK 7. The try with resources statement can be used without a finally block because all resources are automatically closed when this type of try block completes or if it gets an exception. Let's continue looking at this in code. You can see the try block has no code in it and there's also no catch block. Our code still doesn't compile yet either. I'll again choose actions from the first dialog. Now I've got add catch clauses, and here on the left IntelliJ is showing me 2 catch clauses. I will select this option. Okay, so what is going on here? First of all, multiple catch clauses aren't unique to the try with resources clause. You can have multiple catch clauses with either try statement, though I don't think I've yet shown you that. The reason that there are 2 is the first one, the file not found exception, may occur when opening the resource. The IO exception might occur at any time, including closing the resource. Ironically, IntelliJ doesn't like this code. Notice the warning highlight on the second catch clause. If I hover over that, it says catch branch identical to file not found exception, and one of the hints is to collapse catch blocks. Okay, that's an option, but right now I'm going to manually edit this code. I'll change the catch block for file not found exception and add a println statement there. Now my catch blocks have different code blocks, and IntelliJ is no longer giving me a warning on that second catch clause. This code is a lot easier to read because there's no finally block. You don't need the finally block to close this resource anymore, but you can still include it if you want to do logging or something else. I'll add it here and print the same thing I had in the finally block in test file. I'll go back to my main method and call this method instead of test file. Let's run this and see what we get. We get a file not found exception. There are some rules around having multiple catch blocks, so let's play with these a little bit. First, I'll cut the second catch block with the IO exception and its throw statement. I'll paste that above the file not found exception catch block. Changing the order of these catch clauses has introduced a compiler error on the second catch clause. If I hover over that, I see the exception file not found exception has already been caught. How is that possible? As it turns out, Java evaluates the catch clauses in the order we declare them. When IO exception is declared, it catches all instances of that exception, as well as all instances of its subclasses. Because file not found exception is a subclass of IO exception, it gets caught by the first clause as we have it declared in this code. This means the file not found exception clause is redundant or unreachable when specified after its superclass. If you do have code that's different for specific exceptions, you need to declare your clauses in hierarchical order from most specific downward to the most general. I'll undo those last two changes. Next, I'll add a truly catch all clause catching just exception, and I'll put this as the last clause. I'll print that something unrelated and unexpected happened. The class exception extends throwable, so I could include throwable in this hierarchy as well. Let's quickly look at a hierarchical chart of the throwable class, which is the parent class of all of Java's exceptions and error classes. This chart shows you which classes are checked in blue and unchecked in reddish brown. I've previously said that you will know a checked exception because it's not a runtime exception. An error is also an unchecked exception, meaning you aren't forced to catch or specify its type. The error class indicates serious problems that a reasonable application shouldn't try to catch or recover from. I've already mentioned there are two types of exceptions, those that subclass from runtime exception and those that don't. There are a large number of exception classes, and this diagram represents only a couple for demonstration purposes. This hierarchy becomes important for the second variation of a catch clause. Getting back to the code, I want to show you another variation to the catch clause which lets you catch multiple targeted exceptions with a single clause. Instead of listing one type of exception and a local variable for that exception, you list multiple exceptions separated by the pipe character. This kind of looks like an OR statement and helps you remember that this catch expression means one exception or the other. There is still only a single variable declared though. To demonstrate this, I'll use null pointer exception, then a pipe, then illegal argument exception, and call my exception variable bad data. In this case, if either of these exceptions is thrown, I'll print user has added bad data and print the error message. I'll test this out by passing null to the call to test file 2 in the main method. Running this code now to see what happens. I don't get an exception thrown or a stack trace, I just get a series of confusing messages. You can see the code that was in our new catch block got executed. This code printed out, user has added bad data, null. Apparently passing a null to file reader doesn't throw a file not found exception, but a null pointer exception. In this case, I'm not propagating any errors up the stack. The finally clause was executed because that gets called either way, so I see maybe I'd log something either way. After this, the last statement in the test file 2 method was reached and executed. This printed file exists and able to use as a resource, which actually isn't factually correct. When the code goes back to the main method, it checks for the existence of the previous file and doesn't find it. Finally, it prints quitting application, go figure it out. You can't list exceptions in the multi-exception clause that are derivatives of the same class. Look what happens if I now add the more generic runtime exception to that clause. Hovering over the error in this statement, IntelliJ is telling me that types in a multi-catch must be disjoint. This means these types can't have direct relationships with one another. In this case, both null pointer exception and illegal argument exception are subclasses of runtime exception, which means they aren't disjoint. I'll revert that last change so the code compiles and runs as it did previously. Okay, so I'll close this video here. I know these lectures on exception handling were a bit dry, but from now on we'll be dealing with a lot of exceptions as we explore using external resources. The key takeaways are that many of the types to read and write to files are instantiated using the new keyword. Underneath the covers, the constructor opens the file resource, and it's important to close the resource when you're done with it. Using try with resources is the recommended approach, both to make your code more concise and to avail yourself of Java's built-in support for automatically closing resources with that try block. In the next video, I'll be covering some of the most basic classes in the IO and NIO packages. See you in the next video.